Monohybrid crosses. These are SASA marks. Basically, what do I mean by SASA marks? You should be getting all the marks in your paper for these monohybrid crosses. So, what are monohybrid crosses? Basically, mono meaning one. One. So, meaning we're going to be dealing with one characteristic, one trait at a time, whether it's eye color, shape of your nose, balding, or anything else. We're going to be dealing with that one trait at a time. And this basically was done or basically pioneered by the father of genetics, which is Gregory Mendel. So the father of genetics is Gregory Mendel. And from doing this, he formulated some laws to basically from doing these crosses. And he worked extensively with pea plants, for example, and their flowers, basically crossing the two characteristics. Remember, with this guy, you'll see when we mention his laws. Remember, with him, he did not know what an allele is. He called them factors. So, yeah, I think it was factors. Ne? So, when you write the law, if they ever ask you in an exam to mention one of his laws, use factors and not alleles. Write it the way he wrote it. Anyway, we'll get to Mendel and we'll get to his laws later. But after you understand a monohybrid cross, I think after you understand it, you most likely understand his laws a little bit better. So, before we draw this genetic diagram, which is a monohybrid cross, it is important that we start with we know that it starts with a pair of alleles. A pair of alleles. In the previous video, we know that alleles, we can represent them like this: tall, this is, and then the capital letter represents the dominant allele, and then the small letters will represent the recessive allele. Good. And then if you have two identical, if the pair is identical, just like the first one and the second one, we say that these are homozygous. This is basically a quick recap from the previous video. And if they are unidentical, we have a dominant and a recessive one there paired together. These are heterozygous. So these are the terms that you need to remember before going into monohybrid crosses. But without further ado, I will not waste time in explaining many things. I think more practical. I work more practical. So what do you need to know, and where do you need to get your marks? There's a formula to doing this. First and foremost, if you were told that a red plant, which is homozygous, a red flower, a red plant, is crossed with a white plant, which is recessive for this trait, and homozygous. And then they ask you, okay, represent the following information in a genetic diagram. First things first, what are we dealing with here? We are dealing with parents. These ones that are crossed are called parents. That's the first parent generation. So you indicate to us this is P1, the first parent generation, right? Good. And then what do you see first? Do you see that this person, oh no, these flowers have this particular genotype? No, you actually see the physical appearance first, which is the phenotype. So you tell us the phenotype first, and then you'll tell us the genotype. All right, good. Now let's start. What is the phenotype of the one flower? it is red. Yeah? And then it is being crossed. We use the X, the cross, to show that it's being crossed with a white plant. You are done with the phenotypes of what? Of the first parent generation, yeah? The P1 generation. Then, now we wonder, what makes this one red and what makes this one white? We go back to our statement, a red plant which is homozygous, which is homozygous. And red in this case, might we add, red is dominant over white. But it was put to you that it was dominant by all of us saying that this one is homozygous recessive. Then you go. We're going to use the letter R to represent this cross. Okay, we go back. Since this one is homozygous red, and we say red is represented by R, capital letter R, because we say that red is dominant. And it is homozygous, meaning they are identical. So it's capital letter R. It is crossed with a recessive white plant, white flowering plant. The recessive is going to be small letter I. Yeah? And it's homozygous as well. Okay? So far so good? Right. Now, I think for most children, I've noticed figuring out their genotypes is the problem. So we're going to go. Then from there, what happens? For these two, before they beat their cross, meiosis must occur. Né? When meiosis occurs, it will create gametes. Remember, meiosis creates gametes. So this is one gamete, R. I usually circle them to show that these are gametes. Then the other one, big R, that's the other gamete. Then the smaller one from the white one, and then the other smaller one. So these are our gametes. Once we have the gametes, fertilization will take place. Mind you, all of this that I'm writing on the side, this is marks. You need to first give me the phenotype and genotype of the parent generation, then say meiosis took place. And it makes sense. Meiosis takes place. We have the different gametes being produced for meiosis. And then if there was mating involved, then there would be fertilization. So for fertilization, I use what we call the Punnett square. I prefer the Punnett square over the other cross. So you draw your Punnett square there. Almost done. There's my Punnett square. Then you say these are your gametes. Big R, big R. Then small r, small r. Then you go and cross them. This will be crossed with this one, and it will be big R and small r. This one and this one again, big R, small r. And then you come back. This one and this one, big R, small r. And then this one and this one, big R, small r. And then you are done with your fertilization. Now we have them here. Now we have the offspring. The offspring, now you have to indicate to me that okay, we have the first filial generation. F for offspring. And then for those, similarly to the parents, you need to show me the genotype and the phenotypes. They will tell you in the question whether you need to represent this using what? Using ratios. They can either say ratios, they can either say percentage, or they can say proportions or fractions. So I'll show you all. if they say represent this using proportions or fractions, of all of them, we start with the phenotype. How many of them are red? All would be red. In this case, there's no phenotypic ratio, proportions, or anything. And then they say which ones of them are white? None. Okay, since all of them are red. Yeah? The genotype, all of them are heterozygous for red color. Are we clear? So that is an example. Now, let's look at another example here. Here's another one that might be good. Take tongue rolling in humans. Yeah? Good. Tongue rolling in humans, the ability to roll the tongue is because of a dominant gene. Yeah? It's because of a dominant gene. Use the letter R to represent rolling. So you can even do it on the side. R is rolling. So R is rolling and R is also dominant. That's how you can elicit information from this. Now they tell you small letter R is for non-rolling. And it is recessive. Non-rolling, and show this information diagrammatically by means of a genetic cross. How a man who is a roller who marries a woman who is also a roller may have a girl who cannot roll their tongue. Good. Now, where do you start? First things first, we'll come to the genotypes. First parent generation, we need the phenotypes and the genotypes. Before you stress yourself with the genotypes, first start with the genotype. Before you stress yourself with the genotypes, first start with the phenotypes. Now, what are the phenotypes presented to you? They saying to you, genetic cross of how a man who is a roller. If this man is a roller, that means they must have this R. Let's put it, roller. The roller man is a tongue roller who marries a woman who is also a roller. Marries a roller. This is woman. These are the phenotypes. A woman is a roller, the man is a roller. Now they are telling you they may have a girl who cannot roll. Good. Now let's start. For them to be rollers, they must have the allele big R and another one at least. For them to have, for the woman as well, must have big R and another. But how do you determine the second allele here? You look at the statement. It tells you a man who's married to a woman who is a roller may have a girl with a woman may have a girl who cannot roll. Somebody who cannot roll must be like this: homozygous recessive. So they must get this this recessive allele from both parents. So that means these parents, both of them, have a recessive allele for non-rolling. So that's how you determine the genotypes. And then you follow the same method. Meiosis. Meiosis takes place. Then the gametes are formed. Then the gametes, you form the gametes, this one big R, and this one small r, this one big R, and this one small r. These are your gametes. After you have your gametes, you have your fertilization of gametes. When you have your fertilization of gametes, that's when you draw your Punnett square. based on the gametes that you have. Therefore, there you go. Then you have your gametes. Then what are your gametes? Big R, small r, and then big R, small r. Then you fertilize. You cross this with this one, they give you big R, big R. You cross this one with this one, they're going to give you big R, small r. Then you cross this one and this one, big R, small r. And then you cross these two, they give you small r, small r. Then, now that fertilization is taking place, you have your offspring. That's the first filial generation. Please do not forget to mention that this is F1, first filial generation. You start with the phenotypes and the genotype will follow. So, what is the phenotypes? I'm going to start with proportions. Out of 1, 2, 3, and 4, how many of them are rollers? Remember, they need to have at least one allele for rolling. So 1 is a roller, 2, 3. 3 of them are rollers. And then only 1, this one is a non. 1 is a non-roller. So if we are representing this in terms of fractions, this is 3 of them are rollers out of 4. These are the proportions. 1 out of 4, a quarter of them are non-rollers. And then the genotypic ratios might differ from the phenotypic, or genotypic proportions might differ from phenotypic proportions. You might say that you have 1 over 4 that is homozygous dominant, and then 2 of them over 4. What do I mean 2 over 4? These ones, 1, 2 over 4 are also rollers, but they are heterozygous. And then lastly, 1 over 4 is a non-roller. However, they need the fraction simplified. So can I simplify this? If I can simplify this, 2 over 4 is exactly the same as 1 over 2. So there, this is in terms of fractions. If you are called to represent this in terms of percentages, basically you'll take this multiplied by 100. This will be 25%, and then this will be 50%, and this will be another 25%. This is representing this information in terms of percentages. Also this one, you take this, you multiply by 100, that's 75%, and then this one will be 25%. That is how you present them in terms of your percentages. Now, what if they say, okay, represent this information now, not in percentages, but in ratios? Okay, let's go. Same thing. Phenotype, we say that 1, 2, 3 of them are rollers. So 3 rollers is to 1 non-roller. That's the ratio is 3 is to 1. That is your ratio. That is your ratio. And then for these ones, the genotypic ratio might be slightly different. We have 1 big R, that's homozygous dominant, is 2, 1 over 2, that's 2 over 4 basically. Big R, small r, heterozygous roller, and then is 2, 1 non-roller, which is small r, small r. So your genotypic ratio is 1 is to 2 is to 1 basically. Yeah, that is 1 is to 2 is to 1. So that is how you solve it using different methods. So let's let's deal with the last problem. Basically, we'll come back to Mendelian laws. Let's take one problem from the following. Let's use this one. Aha. Let's shift it. I'm interested in this one problem. So if you are told the following, that in humans, dark hair is dominant over blonde hair, which is represented by a small letter D. Dark hair is dominant, which is represented by capital letter D. If a heterozygous dark-haired man had a son with his blonde-haired wife, what would the probability be that the son, see how they want the answer, the probability in fractions basically, be that the son would be dark-haired? You start. P1, the phenotypes of the parents. What you see, the physical appearance first. Now, a dark hair, I prefer to write the full phenotype, man. The way in which they give you is crossed with a blonde haired wife. Those are the phenotypes. Now the genotype. They say that if a heterozygous dark-haired man, meaning we have capital letter D, and then heterozygous meaning they are different, so you're going to have the small letter D, was crossed with a blonde-haired wife. Since blonde hair is recessive, it cannot be this, because dark hair is dominant over it. That means this wife will have to be dark haired, but she's not. She is blonde hair, and it definitely cannot be this. Why? Because these two are dominant for this is homozygous dominant for dark hair, so it must be homozygous. She must be homozygous recessive for blonde hair. Then we move. Meiosis takes place, then gametes are formed. What are the gametes? Capital letter D, small letter d, then small letter d, and small letter d. And then fertilization takes place. Please take note that you need to write all of this. These are Sasa marks. And then you do the cross as usual using your Punnett square. Wait, okay, let's make it more cleaner. And there. So we're gonna have your gametes, and then we're gonna start. The gametes for the male, from the male, D, capital letter D, small letter d. And then that of a female is small letter d, small letter d. Then let's cross them. We're gonna have in this one D, and then from the female you get small letter d. And then from the male again, capital letter D. Then from the female you get small letter d. Then we cross the other one, small letter d and small letter d. And then lastly, small letter d again, and then small letter d. You do your whole genetic cross according to how you're supposed to do it. Then from there, fertilization is taking place. Now you have the F1 generation, the first filial generation. You tell us their phenotype in what? In proportion. That means in fractions. And then the genotype. Let's go. Now, let's look at it. How many of them are dark haired? Let's see. For them to have the dark hair, they must contain the dominant allele, which is capital letter D. I see. I see. Let's see for dark hair. I see one. I see two. Yeah, good. So 2/4 of them is basically dark hair, but we must simplify it. Yeah? 2/4 is the same as 1/2 mathematically speaking. Then 1/2, half of them are dark hair. And then 1, 2. These ones, they are homozygous recessive. That means they're going to be blonde. That's 2/4, which can be simplified to 1/2 are blonde haired. Then we move to the genotype. Genotype, this time the genotypic ratio is going to be the same. Half of them are going to be homozygous, heterozygous, sorry. They are going to be heterozygous dark hair. And then half of them will be heterozygous blonde hair. Then you are done with your cross. But you haven't really answered the question. Well, you have by doing the cross, but you need to, or some questions will ask you, what is the proportion of them? Like this one, what would the probability be that the son will have dark hair like his father? So you're not done answering the question. What is the probability? What is the probability that the son will have dark hair like his father? The probability is, so the probability for a dark haired son is, what is the probability for dark hair? Here it is. Here's your answer. 1/2. Then you've answered the question. Usually this can go for 7 marks. So if the whole cross is 6 marks, then answering the question will be 1 mark. That's 7 marks. 2 chair. For nothing. For absolutely nothing. So that's how it is done. So basically, this is the rest of the questions that you can use to solve these types of crosses. Please do them. Leave your questions on the comment section if you want me to solve them in the next video. But basically, this is how you do monohybrid crosses. In the next video, I'll be showing you basically the difference between a complete dominance type of monohybrid cross, incomplete dominance, and co-dominance. But it was essential that in this video you learn how to do a monohybrid cross using the examples that you are given. Any questions, leave them in the comment section and I'll be glad to get back to you on that one. Thank you.